All right. So for example number 3, well, we did example number 3, but I want to talk to you guys about example number 4. Now, what I want to remind you of, though, before we do example number 4, is that when we go to integrate, we have lower and upper boundaries of some function, okay? And then the variable that we integrate with. There's an interesting thing that you could do. If I have some constant c in front of my, in other words, if my function is a constant, doesn't have a variable x, we know that the antiderivative is going to be that constant evaluated at x, right? In other words, if this was 2, like on example number 3, we said that our function f of x was, I don't know if you guys remember, this was 75. And so when we evaluated that, I don't know if you guys realize this, but we evaluated 75x would be the antiderivative of that. Mm-hmm. So like if this was f prime, then this would be f of x, and ignoring like the plus c, right? So the antiderivative would be the constant times x. Well, that can be evaluated at that this is equal to c times b minus a. Because really what you have is you have c times x, which would be evaluated at b, minus c times a. And so using the distributive property in reverse, we get this relationship. Now this whole thing right here is important because that's basically how we do the integral. We take the antiderivative and then we evaluate the antiderivative at the upper boundary or the upper limit, and then we subtract that antiderivative evaluated at the lower limit. So for example number 4, we're going to try to do something a little more challenging. And then I showed you how to do that on your calculator. So example number 4 is just some more practice. So in example 3, I showed you how to evaluate it on your calculator. Now we're just going to do a couple of functions. So I'm just going to write these functions down. And we'll start with the first one, but we'll do a couple of them. So we have the function x times sine of x. And what I want to do is I want to plug that into my calculator. I think I need to orientate my board real quick. Alright, and so let me clear all this stuff out. So I'm going to say x times sine of x and I'm going to graph it. And so what you have is you have the sinusogenous function that increases with the value of x. And I'm going to have to zoom out a little bit so you guys can see what's going on. So I'm going to set my y from like negative, or my x from negative 10 to 10. And then I'm going to set my y to the same. And then we'll graph it. And so what happens is that x increases, the amplitude of sine increases because I have that x in the front, right? Remember that the leading coefficient of a trig function either vertically stretches the amplitude or shrinks it. So as we go from 1 to 0, the fractions, remember that compresses the wave function, the sine wave function, and then as it's greater than 1, as 1 gets bigger and bigger, it does it like this. And then we have symmetry across the y-axis because we flip when the x value becomes negative, it flips the graph. Anyways, this is the graph, and we're asked to calculate the area under the curve from negative 1 to 2. Okay? So if I were to do that on my calculator, I'm going to do it graphically, and then I'm going to go and do it another way. So here is the, to do it graphically, if I go into the calc menu by hitting second trace, I'm going to choose option number 7. It asks, oops, I got a little carried away. Number 7, lower limit is negative 1, and then my upper limit is 2. All right, so the shaded region is the area under the curve, and my calculator automatically did that for me. And what it did is it went through that complicated process of the rectangular, I think your calculator uses a thing called the trapezoidal approximation method, which is similar to the rectangular one, and we'll talk about that when we get to it. But basically, the area under the curve is 2.04, roughly. Okay. Now, the other way that we could do that, so I'm just going to say that this area under the curve is 2.04, roughly. All right. So now, the other way that I could do that is I could evaluate that using the f(nth) function. So if I go to second catalog, and then f is it cosine? Yeah. So if I come down here to f(nth), that's a function integration program. Whoops, went too far. There's a little delay between my calculator and what it does on the screen. So the first thing I have to do is enter in the function. So I'm going to say x times sine of x. Then I'm going to integrate with respect to the variable x. So I put comma x. And I put comma the lower limit, which was -1, comma upper limit 2. So the program, there's a program that basically goes through and automatically, through an algorithm, calculates those little rectangles, or I think your calculator does the trapezoidal rule, but where delta x is a very small number, so it'll plug in delta x at like negative, or not negative, but 0.000001, and that's why we get an approximation. So when I hit enter, though, I should get 2.04. Okay? So I want you guys to know how to do both. The reason I want you to know how to do both is that if you're going to take the AP Calc exam, sometimes they will give you a picture and ask you what the area under the curve is. And it'll be like a triangle or something. And so they'll say, find the definite integral of this function, but they don't give you the function. They just say f of x. And then they give you a picture of the graph. And it'll be like a triangle. And when you could, by counting the grid marks, you can figure out what the base of the triangle is and the height of the triangle. And you know, the area under the curve is the definite integral. Does that make sense? And we'll do a lot of those examples as we get closer to the test. So that is one of the problems they asked us to do in the textbook. Another one, we're just going to do a couple of them to get the hang of it. I see that one person has their calculator out, so let's get the calculators out.
I did that whole thing on the calculator.
Did you? Well, let's keep going. Oh, don't get defensive. Just get them out. Let's do it. All right. Now we're going to do the same thing with this that we did before. So I'm going to come into my calculator, and I'm going to plug in that function. I'll clear this out. And what was it? It was 4. What was it?
4 over 1 plus x squared.
Okay. So divided by the quantity 1 plus x squared, like that, right?
Yes.
Yeah. So now if I graph that, now I might still have the area under the curve thing drawn, although it probably cleared it out. Yeah, it did. So now they want us to evaluate that from 0 to 1. So if I do it graphically, I'm going to go from here to here. So I hit second trace. Option number 7. Lower limit is 0. Upper limit is 1. So, hey, that number looks familiar.
Wow.
All right. So it's 3.141592, and I bet you it rounded. What number is that? Does anybody want to take a gander or guess? Yeah, I haven't heard that word in a while. Anybody want to take a guess? It's probably pi, and I'll explain that in a little bit why. So now, if I want to do this, if I want to do the same thing again, I'm going to hit second entry, but now I'm going to change my function. Wow, I really hit that a lot. So I had 4 divided by the quantity 1 plus x squared. Oh, I goofed up, didn't I? I have to change the boundaries, don't I? So from 0 to 1. Alright, there it is, 3.14.